Imagine standing on a railway platform. A train suddenly rushes past at more than 300 kilometers per hour. Before you can even follow it with your eyes, it's already far down the track. What's incredible is that this train weighs hundreds of tons and carries hundreds of passengers. At those speeds, air pushes against the train like an invisible wall, and even small vibrations can become a challenge. So how does something this big travel so fast while staying safe and comfortable? Is the secret in the engine, the tracks, or some hidden technology most people never notice? The answer is a fascinating combination of engineering and innovation. In this video, we'll uncover the secrets behind one of the fastest trains in the world, the bullet train. When most people hear the term bullet train, they think of a train that travels very fast. But a bullet train is much more than that. The world's first bullet train, called the Shinkansen, was introduced in Japan in 1964 and changed rail travel forever. Unlike ordinary trains, bullet trains are specially built to travel at speeds above 250 kilometers per hour. Today, high-speed trains operate in many countries and carry millions of passengers every year. But speed isn't achieved by a powerful engine alone. The train, the tracks, and the technology behind them are all designed for one purpose: high-speed travel. And it all begins with something most people never think about: the track itself. A powerful engine alone isn't enough to make a train travel at 300 kilometers per hour. In fact, even a bullet train would struggle to reach high speeds on ordinary railway tracks. Traditional tracks often have sharp curves, road crossings, signals, and slower trains sharing the same route. That means trains must constantly slow down and speed up again. Bullet trains solve this problem by using dedicated tracks built specifically for high-speed travel. These tracks are straighter, smoother, and free from road crossings and other traffic. As a result, the train can maintain high speeds safely for long distances. And once the track problem is solved, another challenge appears: air itself becomes the next obstacle. With special tracks, a bullet train can travel at very high speeds. But another challenge quickly appears: air resistance. At 300 kilometers per hour, air pushes against the train with tremendous force, making it harder to move forward. That's why bullet trains have long, streamlined noses instead of flat fronts. Their shape allows them to slice through the air more smoothly, reducing drag and noise. Engineers spend years testing different designs in wind tunnels to see how air flows around the train. Even small changes to the shape can improve speed and efficiency. This helps the train travel faster while using less energy. But even the most aerodynamic train needs one more thing to reach such incredible speeds: powerful electric motors. A bullet train may look similar to an ordinary train from the outside, but what's powering it is very different. Instead of using a single engine at the front, many bullet trains have powerful electric motors spread across multiple cars. Electricity is supplied through overhead wires and delivered to these motors. When the driver accelerates, the motors convert electrical energy into motion, turning the wheels and pushing the train forward. Because the power is distributed throughout the train, acceleration is smoother and more efficient. This allows the train to reach incredible speeds in a relatively short distance. But moving fast is only half the challenge. How does a train traveling at more than 300 kilometers per hour remain smooth and stable for passengers? Traveling at more than 300 kilometers per hour would be uncomfortable if the train constantly shook or bounced. That's why bullet trains are designed with advanced suspension systems that absorb vibrations before passengers can feel them. The wheels, tracks, and suspension are built with incredible precision to keep the train stable at high speeds. Modern bullet trains also use sensors that continuously monitor movement and help maintain a smooth ride. As a result, passengers can comfortably read, work, or even walk through the train while traveling at extraordinary speeds. In fact, many people are surprised by how quiet and stable the ride feels. But there's another challenge: how do you safely control and manage trains moving this fast without relying only on traditional railway signals? At normal speeds, train drivers can easily see and respond to trackside signals. But at more than 300 kilometers per hour, signals can pass by in just a few seconds. That's why bullet trains rely on advanced digital signaling systems. Computers constantly monitor each train's speed and location and share this information with control centers in real time. The system helps maintain safe distances between trains and can automatically reduce speed when needed. This greatly reduces the risk of human error and helps keep trains running on time. As a result, Thousands of passengers can travel safely every day at incredible speeds. But there's one more challenge. How do you safely stop a train traveling at more than 300 kilometers per hour? Getting a bullet train up to 300 kilometers per hour is impressive. But safely slowing it down is an even bigger challenge. Using only traditional brakes would generate enormous amounts of heat and waste a lot of energy. That's why bullet trains use something called regenerative braking. When the train slows down, the electric motors work in reverse, helping reduce speed while generating electricity. Some of this energy can be sent back into the power system instead of being lost as heat. This makes braking more efficient and reduces wear on the train's components. For the final stop, traditional brakes still help bring the train to a complete halt. But what if we could make trains even faster by reducing friction almost completely? Today's bullet trains are incredibly fast, but they're still limited by one thing: friction between the wheels and the track. So engineers asked a simple question: what if the train never touched the track at all? That's the idea behind Maglev trains, short for magnetic levitation. Instead of rolling on wheels, powerful magnets lift the train above the track. With almost no friction, the train can travel faster and more smoothly. Some Maglev trains have already exceeded 600 kilometers per hour during testing. That's nearly twice the speed of many bullet trains in operation today. As technology advances, high-speed travel could become even faster. But before we finish, let's bring together the key innovations that make bullet trains possible. A bullet train's incredible speed isn't the result of a single invention. It's the combination of many technologies working together. Dedicated tracks allow the train to travel safely at high speeds. Aerodynamic designs help it cut through the air with less resistance. Powerful electric motors provide the energy needed for rapid acceleration. Advanced suspension systems keep the ride smooth and stable. Smart signaling systems ensure safety across the entire network. And regenerative braking helps slow the train down efficiently. Together, these innovations allow millions of people to travel quickly, safely, and comfortably every day. The next time you see a bullet train racing past, you'll know that behind its speed lies decades of engineering, innovation, and problem solving. There's always more to discover. Like, share, and subscribe to Beyond Basics for more fascinating videos made simple.